Hello, Math 45 students. This is your instructor, Cindy Enrique, and we are going to be introducing Chapter 6. So we're going to start on page 1 and section 6.1, Exponential Functions. So here's our definition for an exponential function. For any real number x, an exponential function is of the form a times b to the x, where a is a non-zero real number and the initial value, and b is any positive number such that b does not equal to 1. The domain is all the real numbers, the range is all the positive real numbers if a is greater than 0, and the range of f is all the negative real numbers if a is less than 0. The y-intercept is 0, a, and the horizontal asymptote is y is equal to 0. So I think for now, let's just wrap our head around the f of x is equal to ab to the x. So we know that x is the exponent. And that's how we know it's an exponential function, okay? And x is any real number. So x can go for any real number. All right. So the examples down below, it says, which of the following equations are exponential function? So if I look at, let's say, f of x, well, I have 3 parentheses x minus 2. So this is definitely an exponential function. So this is exponential. For the next one, I have x to the third power. So remember, the exponent has to be a variable. The fact that 3 is a number, this is not exponential. And maybe not exponential function is what I should be writing. It is not an exponential function. Versus f of x is an exponential function, because we had that variable x. Here, that 3 does not represent an exponential function. Here I have the variable x again. So this is definitely going to be an exponential function. And for f, I do not have any exponent at all, so this is going to be not an exponential function. So now that we know how to identify exponentials and non-exponential functions, now we're going to evaluate them. So hopefully now this is going to be on your calculator. So this is what you're going to plug into your calculator. So it says, let f of x be f times 3 to the x plus 1. Evaluate f of 2. So when it says f of 2, this is saying x is equal to 2, plug it in to find y. So, okay, so we have our f of x, it's equal to 5 times 3, and here's the x part, so what I'm plugging in is a 2. Oops. It's a 2, and then I have a plus 1. So I'm going to have 5 to the 3, and then 2 plus 1, that's going to give me 3. So I'm going to have 5. And so now on my calculator, I have 3 to the third power, which is going to give me 27. So 27 times 5 gives me 135. So I know that this is equal to 135. So it was f when I plugged in 2 into my calculator. Okay? All right, so for the next example, it's the same process, except now I'm plugging in a different value. So now I'm plugging in 3. So I know that I'm going to let x equal to 3 plug into your equation. So here we go. So we have our f of x, that's equal to 8. I have my 1.2. That x value that I'm plugging in is 3, and it's being subtracted by 5. And remember, you have to remember your rules of operation or order of operations, or plug it into your calculator directly. So I have 8 being multiplied by 1.2. So then 3 minus 5 is going to give me a -2. So it's going to be 8 times, and this 1.2 to the negative second power is going to give me a fraction. So I'm just going to plug it into my calculator. That might be better because I'm going to get a funny decimal here. So let's see. 8 times 1.2 to the power of -2. So I'm just plugging it into my calculator. On my calculator, I get 5. Oops, here we go. I get 5.5555555. So the 5 keeps going on forever. So you can say that this is 5.5 repeating the 5. So I know that f of 3 is equal to 5.5 repeating. Okay. Well, I hope that makes some sense. And again, this is just making sure that you know how to input these values in your calculator, okay? All right, so the next definition, we have exponential growth. A function that models exponential growth grows by a rate proportional to the amount present. For any real number x and any positive real number a and b such that b does not equal 1, an exponential growth function has the form f of x is equal to ab to the x, where a is the initial starting value and b is the growth factor or multiplier per unit x. So again, this looks very, very similar to an exponential function. So here my key definition is exponential growth. Okay, so exponential growth and exponential function are really, really similar. Okay, all right, so let's put this into play. So our example, in 2006, 80 deer were introduced to a wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponential. Write an algebraic function n of t representing the order of deer, representing the population of deer over time t, number of years since 2006. So I'm like, okay, well, what does it want? What is it asking us to do? Well, it's telling us to write an algebraic function n of t. So that's going to be my goal. So my goal is to rewrite this of n of t function. So some type of function. And in particular, it says that it's growing exponential. So therefore, the function is going to be exponential. So what type of function is it going to be? It's going to be exponential. So now I know that n of t is equal to a times b to the x. Okay, that is our definition of an exponential function. So now I'm going to make a chart to kind of help me out here. It says that I want it since the years, number of years since 2006. So I know my t time is my years. And I also have my population. That's kind of like my y. So it says in 2006, the population was 80 deer. And it also says in 2012, my population had grown to 180. Now I want to be careful because it specifically says that it needs to be the years since 2006. So that means I'm actually going to subtract every year by 2006. So this is your year of reference. So subtract 2006 from every year. since 2006 is kind of year 0. That's your initial value. So, okay, so if I have 2006 minus 2006, sorry there guys, I don't know what I pressed there. So if I have 2006 minus 2006, I really have the year 0 there. If I have 2012 minus my 2006, I'm going to get the year 6. So now I really have the ordered pairs as 0, 80, and 6, and 180, okay? So now I have my 2 years. And I know from the definition that A is my initial value. Well, my initial value is when I have 0 for x. So when x is equal to 0, my initial value, which is A, must be equal to 80. So now I have a lot of information. I have that my n of t is equal to that A value, which is 80, times b to the x power. So the next thing I want to find is the b value. So find b value. So in order to find my b value, I'm going to plug in my ordered pair, which is that 6 and 180. So I have 6 and 180. So here's my x value, there's my y value. So I'm going to plug it into my equation. So then I have my y value as 180. It's equal to that 80 that I had. That b value is what I'm trying to find. And that x value that I have is 6. So now what I do is I am going to divide by 80 on each side. So I have 180 divided by 80, and that's going to give me 2.25. And that's equal to b to the 6th power. So to get rid of to that 6th power, I'm going to raise it to the 1/6 power. So I have my 2.25 being raised to the 1/6 power. And I'm just plugging that into my calculator. So I'm going to get what my b value is equal to. And it's about 1.1447142. Okay. So I'm going to go ahead and round to 3 decimal places. So now I'm going to have my final answer. I'm going to have that n of t is equal to my 80. That's what I had before because that was my initial value. And now that b value that I have is that 1.44 to the x power. Or actually, if I'm rounding correctly, let's do that again. So if I'm rounding to the 3 decimal places, 1, 2, 3, that means that 7 is going to bump me up. So that's actually going to be a 1.45. There we go. And that's how you're supposed to round. And I have it to the x power. I have to be careful. I have to make sure I read this correctly. If this is t that they plugged in here, then I have to make sure that my value is t. So this actually has to be t. Okay. So t is the time, which is my input. Okay. All right, so I'm going to go on to the next problem there. So it says, find an exponential function that passes through the points -2, 6, and 2, 1 analytically. So when it specifically says analytically, that means by hand. So that means there's actually another way of doing this problem just by entering into your calculator, but we want to show you how to do it by hand first. So I have the points -2, 6, and 2, 1. So I have x1, y1, x2, and my y2, okay? So what I specifically want, since it's an exponential function, my goal is to rewrite it as y is equal to a times b to the x power, okay? So I'm going to write my two equations. So let's say my equation number 1, I'm going to have my, remember my y value, so that's going to be 6 is equal to a b to the x value, so let's call that -2. And so for my second equation, I'm going to have my y value, 1 is equal to a b to the x value, so let's go ahead and say that that's going to be 2. So now what we want to do is we can plug one variable into the other. So let's see, maybe if we solve for a over here. So if I were to solve for a, I would have 1 over b squared is equal to a, which is the same as saying b to the -2 is equal to a. So I isolated the a value. Now I'm going to plug it into my equation. So I'm actually going to be doing a substitution here. So for my equation, I have 6 is equal to, and now that a value that I'm plugging in, since I'm doing a substitution, is going to be b to the -2. And then I keep going with my equation, and I have b to the -2. So when I combine like terms, I have 6 is equal to b to the -4 power. So what I can do is I can actually raise this to the opposite power. So that opposite power, or sorry, that reciprocal, so I'm going to raise this to the -1/4 power. So now I'm going to have my 6 to the 1/4 power, it's going to equal to b. So if I have 6 to the 1/4, then I am going to get a number here, okay? Just give me a second. And don't forget that I did it to the -4 power, so I really should have to the -1/4 power there. So that would have been something I would have forgotten unless I zoomed in. So make sure that whatever you do to the one side is the exact same on the other side. So if I raise it to the -1/4, then that 6 is to the power of -1/4. So now I'm going to plug this into my calculator. So 6 to the power of a -1 divided by 4. And I plug that into my calculator, and I'm going to get exactly what my b is equal to. And it's going to give me 0.6389431, and it keeps going. So again, let's go out to 3 decimal places. So 0.6, and if I go to 3, 1, 2, 3, it tells me how I'm going to be rounding, so 639. So now I have that my function y is equal to a, and that b value that I just found is 0.639 to the x power. So now what I need to find is my a value. So in order to find my a value, I just plug in one of the ordered pairs that I have. So it doesn't matter which one, you just pick one. So I don't know, maybe I'll pick the one that's positive, so I'm less likely to make a mistake. So I'm going to plug in this value. So plug in 2, 1 for your x and y into this equation to find a. So I'm going to have my y value, which is now 1, is equal to my a, and I have a 0.639, and the x power that I'm plugging in now is 2. So I'm going to plug this into my calculator. So I'm going to have a 0.639 to the second power, and I get this as a 0.40831. So I'm going to go ahead and divide that by both sides. So 0.40831, divide that by my 0.40831. So 1 divided by 0.40831 gives me 2.4490535 ... is equal to A. So if I'm rounding it to the third decimal, so 1, 2, 3, that 0 tells me to leave it alone. So I'm going to have this as a 2.449 is equal to A. So now I get to rewrite my equation with my A value and my B value. So I'm going to have that y is equal to 2.449. My B value, which I found, was 0.639 to the x power. And that is how you solve this problem analytically, or in other words, by hand. Okay. Now we use those same points, that -2, 6, and that 2, 1. So if I'm looking at this example, we're using the exact same points. These are the exact points that we used. So it's going to be very, very similar to the equation that we got already, except now we're going to follow the steps on the calculator. So remember, this is how we're going to do it on a graphing calculator. So hopefully you guys have that graphing calculator either on your cell phone or on your computer or somewhere. Maybe you're borrowing a friend's in order to do this. So what you're going to do, so step number 1, I'm going to go to stat. So I go to stat, I go enter, and I go into my L1 and L2. So remember, the x values go into L1. So if I'm in my L1, I should have a -2 in there, and I should have a 2 in there. So then for my L2, that's going to be the y coordinates. So I should have a 6 and a 1. That's kind of what it looks like on my calculator. Then from there, it says go to stat. Now I'm going to move the cursor over to calculate, and I go all the way down to exponential regression. So the exponential regression looks like EXPREG. So this is my exponential regression now that I'm dealing with. And then I press enter. I press enter a few times, and then it tells me my values. So it specifically says that A is equal to 2.449489743. And it tells me that my B is equal to 0.638943142. Remember, it's your responsibility to rewrite it as an actual exponential function, okay? So it specifically says find the exponential function. Not just find the values, but actually rewrite it. So when I rewrite it, I'm going to have that y is equal to 2.449, 0.639 to the x power, which is the same as I got from the problem up above. Except now we just did that using our calculator, and that's it. Okay. So we're going to go ahead and try to do this on our calculator again. Now we're going to have two different problems, or two different ordered pairs. So now we're going to do it with these ordered pairs. So, okay, it's the same process. So I'm going to go to my stat, I'm going to go to my edit, and now I'm going to clear my values in L1 and L2. So the first value for L1, I'm going to have 2. And it looks like I also have 5. So in my L1, I have a 2 and I have 5. So then for my L2, I'm going to have my 24.8 and 198.4. So I'm going to go ahead and put that into my calculator. Okay, so then from there I go to Stat, I go over to Calc, and I am going to do my exponential regression. And I'm going to get my values by pressing Enter a bunch of times. So it tells me that my A value is equal to 6.2 and my B value is equal to 2. So don't forget, it specifically says to rewrite or to write an exponential function. Don't just give me the values, but you actually have to write out the exponential function. So I'm going to have that y is equal to a 6.2 times 2 to the x power. And so that is going to be my final answer there. Okay, so now for the next set of problems, it says the compound interest formula. So now we're going to be using a formula. It says the compound interest can be calculated using this formula below. And we have this formula where a of t is equal to p parentheses 1 plus r over n parentheses n to the t power, where a is the account value, t is measured in years, p is the starting amount of the account, often called the principal, r is the percentage rate, make sure it's written as a decimal, and n is the compounding periods in 1 year. So n you want to be careful about, okay? So there are different n values that you can have. So n values. So what I mean is, if something is annually, then you have n is equal to 1. If you have semi-annually, then you have your n is equal to 2. It happens twice a year. If you have something that is quarterly, how many quarters in a year? 4 quarters in a year. If something is monthly, how many months in a year? 12 months in 1 year. And if something is daily, we automatically assume that it's going to be how many days in a year, which is 365 days a year. Okay. So now I have written the different n values that you may see in your homework or your exam or your quizzes. And so let's go ahead and dig into this first example. It says if we invest $3,000 in investment paying 3% interest compounded quarterly, how much will the account be worth in 10 years? So the key word here is that it's compounded quarterly. So if it's quarterly, then I know that I'm going to be thinking about this n is equal to 4 over here. So I know that this tells me that n is equal to 4. That's how many times it happens a year. So now let's think of this. It says if we invest $3,000, well, if you're investing $3,000, $3,000 is your principal amount. That's your initial value. And it also gives me another one. It says 3% interest. So that 3% is equal to my rate. But remember that rate specifically says it has to be written as a decimal. So that's 0.03 is equal to my rate. And then I also have t is my time measured in years. So here my time, 10 years. So I have that t is equal to 10. So now I have all of the pieces that I need. So I know that my money, A of t, is equal to my principal, 1 plus my r over n times t. So I'm going to have my principal amount, that's that 3,000. I have 1 plus my r value, which is that 0.03. My n value, which I said was 4. And it's the n value again, and it's going to be multiplied by my time value, and that time value here is 10. So now I plug that all into my calculator. So I plug that all in and I am going to get my money. So for my money, I'm going to get 4045.05. And remember that money, you always round to 2 decimal places. And so that's going to be my final answer. Okay, so let's go on to the next example. It says a loan is paid off in 15 years with a total of $192,000. It had a 4% interest rate that compounded monthly. What was the principal? So I know from the previous page, and hopefully you guys have this memorized. If not, this is something to write down. But this is compounded monthly. So I know my general equation is going to be my principal, 1 plus my r over n times t, right? That was from the previous page. So I know here that I have 15 years. So 15 years is my time, t for time. And it says that I had a 4% interest. So 4% is equal to my rate. But as a decimal, that's just a 0.04. And it's compounded monthly. So that's my n value. How many months in a year? 12. So n is equal to 12. And it says, what was the principal? So the principal amount is, I don't know. But it tells me that the total at the end was 192. So this is actually going to be my A of t value is equal to 192,000. Okay. So I'm going to rewrite this. So my A of t is equal to my principal, 1 plus r over n to the n times t. So I know my A of t. I know that's 192,000. I know my principal amount, or actually my principal amount is what I'm trying to find. And I have 1 plus my r value, my rate was 0.04, and my n value was 12. So I know that my n value continues to be 12, and I have my time was 15. So now I'm going to have to work out this a little bit more thoroughly than I did the last problem, and that's okay because I'm trying to find my p-value. So I'm going to work from the inside here. So I'm going to have the fraction. So I'm going to have 1 plus, and your calculator should all do fractions, 0.04 divided by 12. And I'm going to raise that to the 12 times 15. So I'm going to get this as a 1.82030167. That's what I end up getting. So that means since I want the p by itself, I'm going to divide by that big number. So 1.82030167 is what I'm going to be dividing by on both sides. Okay, so I'm going to have 192,000 divided by what I just got. So I'm going to get my p-value, and I have 105,477.0249. And remember, I always round my principal amount to 2 decimal places. So I know that my principal amount was 105,477.02. So my principal amount was 105,000. Okay. So really, this is just making sure that you guys can have critical reading skills. So make sure that you guys are reading at a college level and just picking out the buzzwords here and their values, so that way you can plug it into your equation. Okay. So now we have the number e. So it says the letter e represents this irrational number. As n increases without bound. The letter e is used as a base for many real-world exponential models. To work with base e, we use the approximation 2.718282. The constant was named by the Swiss mathematician Euler, who first investigated and discovered many of its properties. So this is actually something on your calculator. So if you're looking on your calculator, that e function, let's see where it is. It's where the ln is. So if you're looking at your calculator, you're going to press the button second, which is at the very top. And then after you do that, you're going to go to ln. Okay? And that'll give you your e. Okay? So just that you know, that ln button, it's to the left of 4. So it's located on the left-hand side of 4 on your TI-84. It's right next to the 4. Okay, so now you're just going to go ahead and plug this into your calculator. So the first one, all we're doing is we're making sure that you can compute it. So e to the 3.14. So remember, it specifically says to round to the 5 decimal places. So I'm going to have this as 23.10387. So that's going to be my first answer. The second answer, it says e to the negative 0.15. So, okay, you just have it now as a negative. So I'm going to have 0.60653. And all I'm doing is plugging this into my calculator. And that last one, it just says, hey, plug 4 into the x value over here. And you can do that. Just plug it in. So you're going to get 3290 point, and it says, remember, to the 5 decimal places, so 89948. So make sure that you guys are practicing this on your calculator so you know how to use this. Okay. Now we have a little bit different of a word problem. The continuous growth or decay formula. For all the real numbers t and all positive numbers a and r, continuous growth or decay is represented by the formula a of t is equal to a to the ERT, where a is the initial value, r is the continuous growth rate per time, and t is the elapsed time. Okay? All right, so let's look at this first example. It specifically says, a person invested $1,000 in an account earning a nominal 10% per year compounded continuously. How much was in the account at the end of 1 year? So because this is continuous, then we know that that's the key word that we are looking for. So I know that the general equation that I'm going to be using is a of t is equal to a times e to the RT power. Okay? So here we go. I know that I have invested $1,000. So that's your initial amount. So remember that your initial amount is your a value. So a is equal to 1,000. And remember, a is your initial value. So whenever it says invested, that is your initial amount. okay? Now it has me as that 10%. So that's going to be my rate. My rate is 10%, but as a decimal, that would be 0.10 or 0.1, okay? Compounded continuously. How much was in the account at the end of 1 year? So here, 1 year, that's my time, t is equal to 1. So I'm going to go ahead and plug this into my formula. So then A of t is equal to that 1,000. And I have E. Remember, that's a value on your calculator. Your R value is 0.10. And your t value here is 1. So I'm plug that into my calculator, and I'm going to get that my A of t is equal to, and remember, since it's money, you always round to the 2 decimal places. So it'd be $1,105.17. So that was your total money at the end of 1 year. Okay. So for our next problem, it says radon 222 decays at a continuous rate of 17.3% per day. How much will 100 milligrams of radon 222 decay in 3 days? So now instead of growing money, you're actually going to be losing money. But again, the key word here is continuous. So since it's continuous, I know my general formula. I know that I have A of t is equal to A times e to the RT power, okay? So now I just have to plug in my values here. So it says that I have my rate of 17.3 a day. And it says that it decays. So the decaying part tells you something about your rate. So if you have decays, that means your rate is negative. So here my rate is a negative 17.3%. So my rate is a negative 0.173, okay? And I want to know what's it going to be in 3 days. So that's my time. So I have that t is equal to 3. And I also have my initial amount. My initial amount is given here. How much will 100 milligrams? So this is my initial amount. So this is A is equal to 100. So okay, now I have all of my working pieces of information. So I have that A of t is equal to my A value. So that A value, I know that's 100. I have E, that's a value on my calculator. It's just like pi, where it's never ending, never repeating. It's like 2 point whatever. Then my rate, don't forget that your rate was negative, so it's a negative 0.173. And I also have my time, which is going to be a positive 3. So I'm going to plug that all into my calculator. And when I plug that into my calculator, I'm going to get a sorry, I just had to plug that into my calculator. So I'm going to get this as 59.511533659. And let's round it to the 3 decimal places. So if I'm rounding to the 3 decimal places, that's here. So that 6 tells me to round up. So 59.516, and it's going to be milligrams as my final answer. Okay. And that is the end of section 6.1. If you guys have any questions, please feel free to email me or contact the Math Success Center as they have online tutoring available. Thank you.